So welcome to the Smartg final demo event. We are located at Aspraspetia settlement, nearby the Agios Nikolaos plant, the fully integrated aluminium production plant. Here we demonstrate bauxite residue utilization in building materials through the Smartg technologies.
In this project we try to valorize this bauxite residue. About 2,400 tons per day is produced of this powder. And we try to find a good solution for it. And for that we have been collaborating with several partners, with 8 partners all over Europe. So we bring technology together from different partners. And in doing so we went from Portugal over Belgium to Poland and Greece. So we brought all the technology together. In Aveiro in Portugal, for instance, they make the beads. Those beads, they were brought to Belgium to make new tiles. And then in Greece, for instance, we use those tiles to do the fire testing. So in that way, we bring all that technology together and we have then the specialties of all those people and all those groups in one big project. The outcome of the project is very wide. So we had in this project many reports, we had about 9 publications. We also went to conferences to broadcast what we are doing. And now in this last final event, we show to the public what we have made. So all the projects will now, one after one, be exposed to the public.
Good morning from our demo event for the Smartg Aramine project. My name is Konstantinos Miltiadis Akas. I am a Dr. Mining and Metallurgical Engineer. I represent MNLT Innovations PC that is established in Greece in 2018 and is expertise in the field of more material sector and geopolymers. MNLT was responsible for Work Package 2, including all the social accounts and website and dissemination activities, dissemination plan, participation in conferences, posters in several conferences, as well as the participation in the fire forum from myself, Dr. Konstantinos Akas.
Bauxite residue is a quite unreactive material. It's in an alkaline environment. So that's why in this work package, in work package 3, we are trying to change that. So we pre-treat the bauxite residue in order to make it more reactive and have good samples, inorganic polymer good samples. So what we do, we take the bauxite residue and then we mix it with different other wastes like clay and fly ash. We melt it at 1300 and then we quench it in water. After we quench it, then we obtain a slag. A black slag that looks like that. Then we mill this slag and we try to test the reactivity of these slags. In our case, we had 4 different mixtures and we did calorimetry, ultrasound and other techniques to test how reactive these materials are in alkaline environment. After we test them and we've seen which slag is better, then we also did samples, and the best sample we had, it's almost 100 megapascals after 3 months. This of course is a very good compressive strength, so then we decided that we would use this material in a higher scale to do bigger samples. So more or less this is what in work package we've done.
Main goal of the Smartg project is to produce fire protective panels. So the material that is engineered has to be very porous and it has to be material with very low thermal conductivity. Of course, we will need also to have the material which will behave well in fire. So during fire, when the temperature is coming up to 1000 degrees Celsius, we want from this material to be fire resistant. We want it to be stable at high temperature and maintain integrity after fire.
In work package 4, the University of Aveiro collaborates with the CUT on the production of geopolymer composites. In the University of Aveiro, we focused on the production of geopolymer composites with the incorporation of lightweight aggregates, for example, with expanded perlite and also with expanded vermiculite. But the novel route was to synthesize a new type of lightweight aggregate, in this case geopolymer spheres, that were mainly composed with bauxite residue. And with these spheres we incorporate in the slag matrix, and we made this type of composites that demonstrate low density and also a suitable mechanical performance, high thermal stability, and also excellent fire resistant properties.
An important part of Smartg project was to upscale developed material and 3D print panels that has fire protective properties. In this task we have collaborated with the collaboration between Cracow University of Technology, ResourceFull was done, and the material which was produced was tested in fire. Very good fire performances were obtained. Also, as you can see on this poster and here, upscaling was successful and 3D printed samples were done, so we are ready for the bigger production. Thank you.
During Work Package 5 we worked together with all the different partners in Smartg, where we upscaled all the development technologies. We have lightweight foamed materials, going from small scale up to large scale, but as you can see there are still some challenges remaining in upscaling these technologies, so further research is also still needed. Apart from that, we made a very thin tabletop containing the slag material. We made dense concrete, self-compacting concrete, using the dense material to produce tiles.
During Smartg project, we evaluated the materials we developed under fire resistance. For this reason, we evaluated under the ISO 834 time temperature curve in a custom-made furnace that can simulate all the time temperature curves. For this reason, the fire resistant materials that we developed here are applied on a concrete surface, as you can see here, and then they are exposed under the ISO 834. And we evaluate the temperature in different depths of the specimen, here behind and here in the middle. One of the best specimens during our evaluation that behaved very well in terms of fire resistance and cracks after heating was the one prepared from University of Aveiro with spheres. This behaved very well since it achieved one of the best thermal gradients, and at the same time, after the test, did not appear any cracks or yielding due to loss of humidity.
In this project we did lightweight aggregates, and on this table you can see all types of lightweight aggregate samples we made. In this case we used metallic aluminium, so we chemically foamed by mixing alkali activated materials with metallic aluminium, and then we created the foam material. In this case, we did a geopolymer composite by using expanded perlite, and the density of this sample is quite low, it's 0.07. And then in this case, this was our best sample actually. We did a sphere containing composite by mixing bauxite residue based spheres with a geopolymer paste, and the density of this sample was even lower, of 0.57. These samples are both made with composite, and in this case my colleague used expanded vermiculite, and in this case she used expanded perlite. You can also see in both cases these materials are fire resistant, so they've been fire tested. This is the reference sample before fire testing, and these are the samples tested at 200, 400, 600, 800, up to 1000 degrees. And all of them, they really perform well. One of the products we developed in this project is a 3D printable material. In this case, you can see a 3D printed plate before and after fire testing. In both cases, you can see there are no cracks and the material performed very well at high temperature. Here, you can see a shrinkage. We got very good results with this photocatalytic coating, and in this case we got up to 75% air purification. Here you can see mechanically foamed geopolymer tiles. They have a low density of about 0.8, And also they've been fire tested up to 1000 degrees, and you can see that they have a really good fire resistance.
Closing this event and taking into consideration the huge problem of disposal that Mytilineos faces with the bauxite disposal, can conclude that the Smartg project results can be a basement, an initiation for Mytilineos to take into account these results and perhaps expanded it in other applications and other activities that they also already make. The applications and the results that we have done are very, very attractive, since they can behave the materials as well as the commercial ones based on the benchmarking we have done. In addition, offer some extra properties, including the photocatalytic and the fire resistance. So we believe that Mytilineos, that has this problem with the disposal of the bauxite residue, can take this initiation, these results, and make several applications, make upscaling, perhaps also make it as a commercial material in the next future. Thank you very much.